For this exercise, we are going to write a function g whose graph represents this indicated transformation. I want to transform f of x 2 units to the left. I have to remember that left is a horizontal transformation. Horizontal goes on the inside, and it's the opposite of what we normally think. So I'm going to rewrite this f of x as g of x equals the absolute value. Again, a horizontal translation goes on the inside. 1/3 x does not change. To transform 1/3 x 2 units to the left, inside I put plus 2. That's the answer to the first one. What I'd like for you to do is to try 2 and 3 and see if you can get those correct, and I'll come back with the correct answer. Here are the answers to question 2 and question 3. To go over this quickly, a translation of 6 units down is a vertical translation or vertical transformation. Remember, vertical goes on the outside, and make sure to simplify if needed. I put -6 outside of that f of x function. I did have like terms of -1 and -6. This portion of the original function did not change. The -1 changed to a -7 because of combining like terms. For number 3, I need to transform this original f of x function down 7 units. That's a vertical transformation. It goes on the outside. So I took the f of x function and I translated it down 7, and then I combined like terms to get this new g of x function. For number 4, I'm going to do a reflection in the x-axis. If you need to, look back of page 6. That will help you know where to put these particular transformations. A reflection across the x-axis is something that goes outside. A -1 goes outside of the function. You're multiplying, the way it looks on the back of page 6 is negative f of x. So you're multiplying f of x by -1. So my new g of x function is going to be -1 times the f of x function. I'll distribute that negative, so my transformation is g of x equals -1/2 x minus 8. A reflection in the y-axis goes inside with x, and you're just transforming the x by multiplying it by -1. So when I make my new g of x function, my 4 is going to remain the same, the addition sign is going to remain the same, the +1 is going to remain the same. I'm just going to multiply x by -1. So my final answer is going to be g of x equals 4 plus the absolute value of -x plus 1. For number 6, a vertical shrink, if you look back at vertical stretches and shrinks on the back of page 6, these values are the values I use for A. These values go on the outside. You're doing 1/5 times f of x. So I'm going to take this f of x function, -5x, and I'm going to multiply it by 1/5. 1/5 times -5 is going to be g of x equals -x. That's the transformation of f of x equals -5x to a vertical shrink by a factor of 1/5. For number 7, a vertical stretch by a factor of 4 means I'm going to multiply f of x by 4. So g of x is going to be 4 times f of x. Be very careful when you multiply this. You're doing 4 times this and 4 times this. When you do multiply 4 times the absolute value of x plus 3, please leave it as 4 times the absolute value of x plus 3. 4 times 2 is positive 8. So my new function is g of x equals 4 times the absolute value of x plus 3 plus 8. For number 8, I'm going to do a horizontal stretch by a factor of 6. When you do horizontal stretches or shrinks, you have to do the reciprocal of this number, 1/6, and when you do that, it goes inside with f of x. You're going to only multiply the x portion by 1/6. So what I mean by that is my new function g of x is going to be 3 times 1/6 times x minus 9. Can I simplify that? Yes. 3 times 1/6 is 3/6. 3/6 x would be 1/2 x. So g of x equals 1/2 x minus 9. That's the answer to number 8. For number 9, I'm going to do a horizontal shrink by a factor of 1/4. Remember, I'm going to do the reciprocal of 1/4. So I'm going to do f of 4 times x. When I rewrite this function, g of x equals, keep your negative sign. For the moment, keep your 8. Inside with x, I'm going to put 4 times x. Close that absolute value, minus 4. Now, can I simplify? Yes, I can. Keep your negative sign. Absolute value of 32x minus 4. And that would be the transformation of f of x to g of x. Moving on to page 14, transformation of graphs. We're going to identify the function family for 1 through 4. Then we're going to compare the graph of f to the graph of its parent function. So the function family here is linear. The function family for number 2 is constant. The function family for number 3 is absolute value. And the function family for number 4 is quadratic. We can look at the equations to figure out the transformations. This particular problem has 3 transformations. We have a reflection across the x-axis. We have a vertical shrink of 1/4. And we have a translation of up 8 units. Looking at question 2, to go from what we call the parent function y equals 2, I would go down 1, 2, 3, 4, 5 units. So there's only one transformation here, down 5 units. For number 3, there's only one transformation. This 5 tells me that this is a vertical stretch of 5. I know this is a stretch because I'm multiplying by 5. I'm multiplying on the outside, so that's why I know it's a vertical stretch of 5. I know this one is a vertical shrink because of the 1/4. The negative just means a reflection. The 1/4 is outside of x, so that means it's a vertical shrink of 1/4. The last one, we have two transformations. We have right 1, the -1 is inside, horizontal transformation, so right 1 up 4. For the next part of this page, we're going to graph the function and its parent function. And what I'll do first is go through and graph the parent functions. I have graphed the parent function for each of these, the linear parent function, the constant parent function, and the absolute value parent function. The -7 is on the outside. That means to take my graph down 7 units. These graphs are going by 2, so I'm going to take this graph down 2, 4, 6, 7 units. Take this down 2, 4, 6, 7 units. And this one down 2, 4, 6, 7 units. And I'm going to try my best to sketch the line that would go through those 3 points. This is the graph of that function. For the second one, I'm going to go down to -9 and draw a horizontal line. That would be the transformation of that function. For the next one, I'm going to take my absolute value function up 1 unit. So this is going by 2's as well. I will go up 1 unit here, up 1 unit here, up 1 unit here. And then I will try my best to sketch an absolute value function. And that's the transformations of those functions.